Good afternoon. First, my apologies for my Portuguese, which is non-existent, so I will give this in English, but I'm sorry and hope to keep you awake following lunch. I'm Chris Marrion. I would like to, again, thank you all for being here on this very important day and a lot of the interesting discussions, and thank all of our hosts and significant leaders who have been here before, as well as the U.S. Embassy here in Brazil for helping support this trip here. So what I'd like to talk about for a little while is, the title is Newest Approaches and Technologies for Fire Safety and Heritage Assets. This doesn't mean we're at the bleeding edge of technology in the world. We're somewhat a little bit behind in the fire safety industry. So a lot of this is relative and relevant to the fire industry in terms of what we're doing new, in terms of kind of the leading edge, in terms of approaches and technologies and things like that, to just kind of give you an idea of kind of the state of the art within the industry. I wanted to talk about where we're at in terms of approaches to working on historic buildings and cultural heritage, and how we go about approaching that from a disaster risk management perspective. Talk a little bit about some of the assessment tools and some of the new things with technology and systems. And then also just want to talk as well about the importance of just keeping things simple. And a lot of times just a lot of common sense goes a very long way. Recent approaches, and you've probably seen this or some format of this in terms of disaster risk management, starting out with mitigation and preparation before an event happens. What can we do to limit the hazard from happening? Can we try to prevent it? Can we try to reduce the magnitude? If not, what mitigation measures may we need to put in place in order to minimize or lessen the impact from that particular disaster? It could be systems, it could be training, it could be prevention methods, and a whole lot of different tools at our disposal. We then forward to having an event, which could be on the order of seconds or minutes or hours or days. Following that is a response period, which then we're looking to fully address the particular event that has happened, and then eventually, once we're finished with the response, then move into a recovery and repairing and building back. And it's a cyclical, iterative process. In terms of, in particular, over the last several years, the industry has been moving more within this diagram. A lot in the past was more on response and recovery. We're now pushing into trying to deal with disasters beforehand, and much more focusing on prevention and mitigation, as you could imagine, for many, many reasons. From there, general approach, then looking a little bit deeper in terms of what we would call a risk-informed, performance-based approach. It's helping us understand what it is that we're trying to achieve, what are the hazards and issues that we need to deal with, and then coming up with measures that hopefully end up allowing us to achieve what it is that we really want to be achieving at the end of the day. So quickly walking through this, and again, you may be familiar with a lot of this, but starting out, with the project, where we're at, what we're trying to do, who are the stakeholders, what are the different resources, what are our limitations, just basically kind of laying the groundwork for the overall project. The next is our goals and objectives. What are we trying to do? Some are very high level, protecting the life of the occupants, of the people in the building, and within the community, protecting the lives of the emergency responders and allowing them to get into the buildings and be able to perform the operations that they need to safely. But then we also look at other goals and objectives in terms of protecting the heritage, in terms of the overall structure, in terms of protecting the contents. And it's not just saying, look, we want to protect this and not have any damage, because there's obviously a relationship with how much money that would cost in order to protect it and make sure that there's absolutely no damage. So it becomes kind of a balance. But it's important then to start to quantify some of these things. How much damage, what type of damage is going to be acceptable to us and to the different stakeholders. That may vary. But for instance, just taking art. Some art may be more susceptible to higher temperatures, or looking at humidities for extended periods of time, or some of the products of combustion, things produced during a fire, are acidic, and if they get onto paintings or electronic materials and so forth, they can have short-term and long-term impacts. So It's just understanding what we're trying to achieve and getting into a little bit more level of detail as we move forward. And then looking at as well, once we start looking at mitigation and prevention measures, to what degree do we want them to be able to impact the structure while they're being installed? What about the aesthetic looks of having smoke detectors in the room? And are there other options that we can use so that we don't have those obviously sticking out in a very ornate ceiling? But understanding some of these things are important early on as we go forward. From there, then looking at credible events. Is it just fire? Are there other types of disasters and hazards that we need to be dealing with? Sometimes yes, sometimes no. Sometimes we may have earthquakes that then have fires following them. So we may have multiple events that we need to be addressing. From there, we then look at fires. We talked about statistics earlier, and it's very important to look at and understand where we have been in the past and how that helps inform us going forward. But you had seen before some of these showing up in statistics from the electrical and open flames and cooking and those types of things. But it's going through and understanding what there is in the building. It's not to say we can't have open flames in a church. It's more about understanding what we have, how much of a hazard is that, how do we then go about making that safe? If that's what the functionality is and the operation of that facility, how do we go about helping protect it and make it safe? From there, once we understand what we're trying to do and where we're trying to go, how do we end up getting there and looking at prevention and mitigation measures? And this is looking at kind of a balance between a fire and trying to limit it from happening and how big it can grow and how quickly. And then if we can't obviously make it 100% that we're not going to have a fire, let's try to limit its size, and knowing that we can't have an absolute zero probability, looking at mitigation measures. And we often have a number of different things that we can do to compartment and contain the fire so it doesn't get large. Having detection so that we can alert people and the emergency responders, and so forth. Egress in terms of suppression. So it doesn't mean we need to be doing everything. It's really looking at the individual building and tailoring the solutions to the hazard and what we have as a building on kind of a very individual basis. So that obviously is good and not so good in terms of having a large fire and not so much protection there. From there, once that is in place, and getting into design documents and working with the architects and engineers and local authorities in terms of moving forward and implementing the restoration or construction work. There's just a couple of things quickly in terms of this process, in terms of some of the value that it brings, is flexibility and being able to hopefully quantify to a better degree, are we able to really achieve the objectives that we think we are going to, and that helping to make decisions that are more informed. Is this really going to work? Should we be spending our money here, or is it going to be better value to put money in terms of other different mitigation measures? Obviously, helping people be able to get out and understanding different threats, bomb threats, other types of natural disasters, not just fire. Are the evacuation systems able to get people out? And then obviously looking at cost-effective solutions, and with limited resources that we often have, is this the best way to be investing those resources? Assessment tools. So we have the structure, then looking at what are the issues, how will fire behave, how will the building respond, how will the occupants behave. And in terms of understanding that and understanding fire, I just thought for a moment it may be of interest just to take a look and understand when we see fires on TV, when we see fires in a fireplace or what have you, we have time versus the size of a fire. Fires typically don't grow in a linear fashion. They grow exponentially. So when you double the time from, say, 1 minute to 2 minutes, the size of the fire increases not twice, but a factor of 4. So every time you double time, you quadruple the size of the fire, and it just grows very, very quickly. If we can suppress the fire, then the curve obviously comes down, and if not, it continues to grow. So what are we trying to do? So a fire starts, what do we need to do? We need to detect it, we need to notify the occupants, we need to notify the emergency responders. They need to respond, and then they can begin to put the fire out. But as you can see by how quickly fires grow, every second, every minute really counts. because the fire is growing so rapidly. So the more delay in terms of not having any kind of detection system, if we're not then processing that signal and sending it to the fire department very early on, if they have trouble in traffic getting to the site, if there's a gate around our facility, if there's locks, you can see that time continues and the fire grows and doesn't wait for the fire service to get there and to start putting water on the fire. So everything we can do, just keep in mind, it's very time-based. Are we reducing that time frame, or are we allowing that to potentially increase? And how can we help enhance that reduction? Putting in different types of detection system, you know, from having a human there to see it, to smell it, obviously very good, but quite expensive. Putting in smoke detectors are better than heat detectors, and you can see, obviously, smaller size fires can be detected by those means. One of the other things I thought is important too, just to understand in some of this and developing strategies, is just fire is based on physics and science, right? We're producing heat, and then you put water on the fire, and the water is actually absorbing the heat. So the more heat you absorb, then the fire gets smaller and eventually extinguishes, which means, again, going back to physics, if you have so much heat being produced, there's a quantity of water that will put that out as long as it's effectively applied into the fire. But then looking at this, if you have a small fire extinguisher, it's relatively small fire you can put out. If it's a small rural town with limited fire department, then that could get a little bit larger fire, and then getting into more of a city context, you can get even a larger fire from there. Looking at some of the different research, there's a lot that's been happening on a fire basis, and the video isn't working at the moment, but you can get an idea how quickly fire happens. It's quite amazing to watch some of the different videos. And again, we don't have a lot of time with some of these fires. This reached this point within 20 seconds of basically flashing over this typical living room. There's a lot of work going on in terms of new technology, in terms of looking at human behavior and how people respond during emergencies. It's important to understand. We heard earlier today about different extinguishing agents. There's been reports out looking at different extinguishing agents on different types of materials. It's very interesting to note. A lot happening in terms of computer modeling and looking at evacuating and how long it takes people to get out, looking at where we may have congestion. Looking at fire smoke behavior and how that grows and develops, and if we have mitigation measures, how that may impact the movement of fire and smoke, and being able to predict when detectors may operate or when sprinklers may operate. Looking at the behavior of structures and fire and how long the building may stand or types of damage that may happen. Also just using satellite technology and being able to take that and looking more, not just structures, but wildlands and sites, and looking at fires using that, and again, getting early detection for, you know, out in the middle of wildlands that may not go detected for some time. Detection, quickly, some new technologies, just looking at wireless systems, so we're not running wires and impacting a lot of ornate ceilings. Beam smoke detectors are great, that we can span long spaces, and some new technology with that. With some of the air sampling you may have heard of, again, these things are very good, very sensitive, but are fairly well hidden behind some of the ceilings, and there's some new technology and recent developments with using much smaller tubing to be able to hide it that much more effective and be able to detect more specifically where that fire is, so that you don't go into an area and try to search for an extended period of time. Using video and combining security and video detection for looking at fires and trying to detect it from a video means. Again, a lot happening with connecting your fire alarm panel to mobile devices. Sprinklers, just to talk for a moment, I know there was a question and maybe jumping the results of that, but sprinklers are a very, very valuable component. I don't know if Jose is here. Do you want me to talk about this, or? Okay. Okay. Sprinklers are a great asset to have in terms of protecting any building, but especially historic buildings. We see in movies, we see in Hollywood that they have had a very negative impact in our belief in terms of how they operate. Sprinklers have often a glass bulb that at 75 degrees centigrade the liquid expands and the bulb releases. So it's just more that sprinkler right close to the vicinity of where the fire is releases and you get water. Not all of the sprinklers go off. If you blow out the candles on your birthday cake, they're not all going to go off. If you pull a manual pull station, they don't all go off. It is just the ones in the direct vicinity of where the heat is, and you usually might get 1 or 2 or 3 sprinklers that discharge during a typical fire. People get worried about water. What do you have running through buildings? Lots of plumbing pipes, hot water, cold water, sanitary, drainage, but everybody gets worried about sprinklers and sprinkler water, but nobody thinks about the hot water and the cold water. These, at least, we monitor at the fire alarm system if there was water flowing, but your hot water, if you get a leak in your hot water pipe in the middle of the night, you're not going to know until somebody shows up the next morning. So these are pressure tested, all kinds of fantastic things, and just in terms of reducing damage, in terms of water damage, again, keep in mind these are about 80 liters per minute versus the fire department at 500 to 700 liters per minute of water. So they're going to show up and put a lot more water on fires. This, you have 1 or 2 or 3 sprinklers going for a little bit of time. When you think about and reading the newspapers about water damage, and there was a fire and the sprinklers went off, you have to remember to compare not to no damage and sprinkler water damage. Think, remove the sprinklers and look at the fire damage. And then the fire department coming in and all that water, and compare that to sprinklers, not doing nothing to the sprinkler water. It really keep in mind what you're comparing it to. So that I will continue on my public service announcement. Water mist systems, again, very high pressure, very good. They do a lot in Norway and Sweden with protecting the old wooden churches. But it's very fine mist, high pressure, and it's very, very efficient. You create a lot of surface area on the small water droplets that is very efficient at absorbing the heat. So not the newest technology, but they're being applied much more. We did the attic at St. Patrick's Cathedral in New York with one of these systems. And oftentimes they're self-contained. They don't need a lot of water. So for remote areas, a lot of benefit. Other things in terms of some, again, this is, you know, in recent times, the last couple of years, but some other tools, people ask a lot about electrical wiring, and there's some things that might be able to be done getting in electrical contractors, but also looking at infrared and looking at where wiring, where junction boxes and so forth may be getting hot, and understanding where a problem may be occurring. Also, this was just interesting looking at the internet in terms of some of the information that's now available in all the buildings that are out there. This is from Google Arts and Culture on the National Museum, and just looking at, you know, I think they're trying to crowdsource and getting photographs, but from our perspective, you know, just helping to understand some of the different construction and seeing, you know, there was a wood ceiling and wooden floors in there, looking at the exhibits and the type of materials, and just helping understand from a remote perspective on what was in there, looking at some of the compartmentation and the doors that were in there to try to help, you know, just look at understanding that a little bit. You can see a lot of fire extinguishers are throughout the whole place. Smoke detectors is a little bit difficult to see on here. One of the other things, just in terms of technology, and again, just helping in terms of training and people able to use fire extinguishers. I may not be able to do a live fire test, but at least these are very good simulators in terms of at least being able to work with a fire extinguisher. Firefighting robots, you may have seen some of the photographs from Notre Dame where they did use these to go in, but you'll probably be seeing more of these in the coming years. The last thing then was just looking at, there's a lot of things, you know, going on in terms of the approaches and some of the technology and so forth. But I think in terms of solving and addressing a lot of the issues, it doesn't necessarily mean all of the latest technology, all of the latest equipment, and all needs to be applied and used to solve a lot of these issues that are around. It's great to know that they're there, but it may not be always relevant to run computer models or to use some of the latest equipment, or, you know, what do we do if we don't have a large fire department? Just running through it, I won't go through this in too much, but when you start to look at statistics, when you start to look at reports of what happens in fires, especially in historic properties and our cultural heritage facilities, there's a lot of very, very common themes, and they continue to happen, and it's usually not just one thing. It's a lot of things that just line up kind of for the perfect storm. There's a lot of ignition sources. There's a lot of combustible materials. There's typically no detection. There's typically alarm or notification to the emergency responders. Limited or no suppression systems, limited compartmentation to limit the fire from growing vertically and horizontally, and limited plans and procedures in place. And these are the 10 or so things that we just continue to see. So knowing that, that then helps us feed into looking at strategies and what can be done. And just going back again, it doesn't necessarily mean we need the latest sprinkler system, we need the latest fire alarm system. It's fantastic if we can, but again, resources are limited. There are things I just wanted to end this with is it's not always the latest and greatest technology. There are a lot of things we can do today. There are a lot of things that are low cost but have a very substantial impact in safety. It's, again, a lot of this is just common sense when we start to think through, but no smoking, if we have candles, keep them away if they do tip over from things that can burn. If we heard earlier about Windsor Castle and having a halogen light up against a curtain. These things we know, don't put hot things next to things that can burn. Let's keep them separated. Upgrade our electrical if we can. Simple things, changing out light bulbs from halogen or incandescent lights to LED or LCD lights. It can make a significant difference in reducing that. What happens in terms of attics and basements over the years, decades, centuries? We get huge accumulations of rubbish, whether it's up in attics or down in basements, and we have our artwork or what have you. The hazard is down below, which I think we heard before. It's not typically in the gallery spaces, from what Jose was saying. Does all of this need to be here? Can we remove it? Can we store it at some other site? But again, does this cost us a lot of money, but the impact that it then has on us? Again, this costs really nothing to clean up, and just looking at the potential, we've got old dead trees in the background. There was a castle in Krasnohorka that in Slovakia that burnt. There were two 15-year-old boys smoking cigarettes at the bottom of a hill. They lit the field on fire, and it grew up. It caught the trees on fire and burnt the castle down that had been there for 500 years. This was about 3 or 4 years ago. Fire separations, we put in electrical equipment, we put in HVAC, mechanical equipment, and we have very large penetrations. These walls at one time were there likely to help contain a fire and to provide fire separations. Now when we remove them, the fire is going to pass right through. Windsor Castle, I think, involved 100 rooms, and anything we can do in terms of compartmenting to limit the spread, to help keep that fire small, again, so the fire department can do it. But passing that, having doors that we keep closed or are on self-closers, these things don't, again, cost a lot of money but have significant impacts. If we have systems, we talked a lot about maintenance, and this is, you can see there's probably none of these detectors are working. It's great, we have smoke detection, but is it really going to work at the end of the day, and has it been tested? But again, very, very important points. Simple things. This was a monastery in the middle of Bhutan. They're sending a monk up to the 3rd floor during a fire to ring a bell, which is great in terms of everybody else being alerted, but the person going up to the 3rd floor, so why not just put a rope down to the ground level so somebody from the ground can begin to notify. Again, sending a signal, not just that it goes off at the fire alarm panel in the middle of the night and nobody is there to call the fire department. Can we connect it? Again, not a lot of money, but so that we're calling the fire department once the panel goes into alarm 24 hours a day. One of the last things is just, again, looking at, can we get the fire department close to the building? Can they get through the gate? Are there locks? Do they have keys? And I think this was mentioned earlier today. Again, this is not costing anything, but again, seconds and minutes are going to be spent getting the vehicles, getting the people in there to begin fighting the fire. One of the last big things is we've seen in Paris, restoration, and this is a whole other topic, but again, we have strategies when the building is fine and operational, but we really need fire strategies for what's happening during that restoration period. It is a very hazardous time, a very critical time in the life of a building. You have a lot of hazardous things going on, cutting and welding. You're introducing a lot of potentially combustible materials. You removed doors potentially to go have them restored. You put up fencing for security. Now the fire department can't maybe get to the site and get up to the upper floors readily. So there's a lot of things that the overall level of safety there may be diminished and we introduce hazards, but it's really looking at these very, very closely during that time and having very specific plans, and also working with the people that are on site doing the work, and creating awareness and training and continually working with them. They're the biggest ones that are going to help. They're the biggest ones that are probably potentially going to start something. So how do we help create awareness and work with them and train them to limit these types of things from happening? And one of the last things is just looking at engaging the overall community, emergency responders, the people that occupy the building, the people that run it. It's all a community. We're all impacting the solutions and problems from different perspectives. And just to end is just looking at, again, keeping things simple. Again, the approaches are the same. It's just how can we go about implementing that with the resources that we have. So it's great to be working in towns and cities that we are able to install all kinds of equipment, that we have a fire department or a fire brigade that can respond. But what happens to some of our cultural heritage and sites that are out in very, very remote areas where we don't have these? And again, it's just looking at what resources that we have available that are going to be long-term sustainable, to put in fire alarm systems in some of these remote areas where there's nobody to test and maintain, that put in sprinklers where it gets to be negative 40 degrees centigrade in the middle of the winter time. There's nobody to maintain and service those. Is that really a long-term, sustainable, useful means in terms of what resources we may have? And just, again, this was looking at having some of the younger monks in this particular monastery be kind of the detection system for an hour or two a day, using the conch shell that they were using to call in people for meditations, that they were very, very tuned into hearing and listening and understanding, and whatever response that they could, even if it was the wool blankets, and if they could at least try to limit the fire or try to keep small fires from growing larger, fine. Obviously, if it was getting much bigger, then get out. But there's limitations in many, many ways, but there's some things that can be done at least to try to reduce the probability of some of these happening. So with that, just thank you very much for your time and for listening. Thank you.